Hello and welcome to the third video in the series on control structures. In this video, we'll primarily focus on decision-making logic, the selection structure, and then look at a few examples in terms of how we can enforce a particular range in our code. For instance, if we're trying to restrict age limit, how do we actually do that with a decision structure? So we'll take a look at that, and we'll take a look at the switch statement as well as this thing called a ternary operator. All right, so selections within range. So here's an example, a code example in terms of how we can actually restrict or enforce that an end user would enter in a certain age, and we could check to see if that age is actually in between a certain range. So for instance, in our code here, we have lower driver age at 16, and then we have upper driver age at 120. Here's the conditions that we need for that. We have age is greater than or equal to lower age, driver age. But then we have the AND operator, and then that's going to basically say that both of these conditions have to be true. And then we have age is less than or equal to upper driver age. So for both of these, for them to be able to rent a car from Harvey Car Rental, both of these conditions have to prove to be true, or else it'll just say, hey, you can't rent this car from this rental company. Let's actually take a look at this code. I want to play around with it for a little bit. So I'm going to open up a coding playground called Online GDB and paste this code in. All right, so let's go ahead and run this program here and see what outputs here and make sure everything is running correctly. Yep, so our logic is working and we're able to rent a car from Harvey Car Rental. The one thing I want to point out is that you want to make sure that you're using the correct relational operator. Let's say, for instance, that we don't want to include the age 16. So they have to be above the age 16 and they have to be lower than the age of 120. So if you want to modify this, we can do that. To enforce that restriction. And so let's say, for instance, if we put 16 in here, we should get not able to rent car from Harvey Car Rental. So if we run this, there we go, right? So that's one thing to be cautious of, to make sure that you're using a correct relational operator, especially when you're enforcing a particular range, so that you can get the intended output that you're looking for. All right, so let's rearrange this problem to use the OR operator. And so here, the OR operator is the double pipe. And so what we're going to do is do the same enforcement, but using the OR operator. And with the OR operator, only one of these conditions have to be true. So we're going to change this around. We'll say, while age is less than lower driver age, and then while age is greater than upper driver age. And then we'll just switch our statements around. So what it's doing here is that we're enforcing a lower range, enforcing that a number cannot be entered in the lower range, and then enforcing that a number cannot be entered in the upper range that's greater than 120. And just showing you both ways so you can kind of see how you can use this in your programs. And then let's see here. Let's get rid of this one here. All right, so now if we run this program, what's happening here is that if an end user enters an age, let's say, for instance, age that is, let's say, 15, right? We could have kept it at 16. So if they're 15, 15 is less than the lower age, driver age, but 15 is greater than, I'm sorry, 15 is not greater than the upper driver age. And so in this case here, it will go into the block because age is less than the lower driver age. And so let's run this program. Yep. And then let's say if we enter age to be 130, 101. Or, I mean, some people live to be 130. So it works if now they're able because they're within the range. But then if we do, let's say, beyond the range of 121, then this should give us not able to rent car from Harvey car rental. So again, this both ways of doing it when using the AND operator and also using the OR operator. One common question that you'll typically get is there one way that's better than the other in terms of enforcing a particular range? And really, you could do it either way. And that's why I showed both ways with the and OR. It could get tricky, so you just want to have to make sure you test it, make sure you're getting the intended output that you're looking for. All right, let's jump back to our slide. And again, just be cautious of, are you trying to include a number within the range? For instance, you're trying to include that they can be 16, you would use greater than or equal to, or if you're trying to include 120, so that's an applicable age that they would have to be, then you want to use the less than or equal to in this example. Selections within range. A lot of times you'll receive a problem, and let's say, for instance, you're trying to, in this case here, they're trying to figure out which discount you will receive. And so if you order between 0 and 10 items, you will receive no discount. 11 and 24 items, you will receive a 10% discount. And this is a common coding solution that you may be asked to implement in the future or whatever it may be. But let's talk about a strategy in terms of how we'd actually code this out. And so you'll see that they give you the pseudocode here down below, and also the flow chart of how this looks. So this is correct. But let's talk a little bit more about what they did here. All right, if you're ever presented with a particular problem of this nature, where you have to determine some type of what somebody will receive based on multiple ranges, the best thing to do here is to pick a side of the range, right? So for instance, this is 0 to 10, 11 to 24, 25 to 50, 51 or more. In this case here, let me just get my pen out. I want to choose a side of the range. In this case here, I'm going to choose the upper bound of the range. So 10, 24, and 50. And I'm going to use those upper bounds of the range to structure out my conditions. And that's what they did in this problem here. They said items ordered, is it less than equal to range 1, which is 10, right? So if it's anything that's less than equal to 10, it'll receive 0, right? And so here, customer discount will equal to discount 1, which discount 1 here is 0, right? And you don't have to do two particular conditions. You don't have to say items ordered is greater than equal to 0 and items ordered is less than or equal to range 1, right? You just have to, if you do this cascading of the ranges here, it'll automatically detect which range, which discount you should receive. So again, just to clarify what I just mentioned here, you'll see that each one of these have one condition. A common problem that I see is that folks would like to put two different ranges to enforce in between, let's say, for instance, 11 and 24. So some people would say items ordered is greater than 11 and items ordered is less than equal to 24. That's not needed in this particular scenario. You really only need one condition if your other decisions are nested within another structure. And then at the end here, if there's anything that's above 50, then they'll automatically receive the discount of 20%. So these are two different examples so this is like one range, right? And then this here is multiple ranges. So you may you may encounter scenarios like this when you're coding out problems. If you have one range or you have multiple ranges, right? Just think of the approach that you just have to pick one side and then structure your conditions in this cascading order here. Here's some things you want to be cautious of. Avoid dead or unreachable paths. Never ask a question if there's only one possible outcome. And this is kind of what I was just mentioning on the previous slide. Avoid asking a question when the logic has already determined the outcome. So both of these is kind of what I was alluding to in the previous slide. Another way of making a decision, another decision structure is called a switch statement. And within a switch statement is pretty much the same as an if-else block. It's just a different syntax. Sometimes some people prefer to use a switch statement when you're using like fewer comparisons, or the information that you're comparing or you're trying to make a decision on is finite, or it's always going to be somewhat static. So for instance, days of the week or months of the year, those may be a good case to do a switch statement. There are two reserved keywords within a switch statement. One is break and one is default. And the break is that once the solution is found, it'll break out the entire structure. So here we have our opening bracket, and then we scroll down here, we have our closing bracket. But once the case proves to be true, it'll break out of the structure, and it'll go immediately to the end of the bracket and execute the rest of the code. The default is that if, let's say for instance, that we have int day equals 2, the switch statement is going to receive the value 2, and it'll look at each case, 1, 2. In this case, it goes into this block. But let's say, for instance, that we use 7 here, or let's use 9. It'll enter the switch statement. Day will hold the value of 9. It'll go through each case, but we don't have a case that has the value of 9, so it'll just default to invalid input. All right, so let's do a quick example. I want to modify this code here just to show you some of what you can do with a switch statement. So what I'm going to do is copy this code, and let's go back to our web-based editor, and I'm going to paste this in. And I'll just tab it over. Good coding practice to make sure everything is properly nested. Okay, so here what I'm going to do is change this a little bit. Let's say that I'll keep the numbers. Let's say I'll change this to 8, 9, 10, and 11. But watch this here. What I want to do is get rid of these break and system output statements here. I'll just say, what I'm doing here is kind of creating a simple program to determine if the hour that they entered, let's say the time of day they've entered is AM or PM. So if they entered in between 7, we do another case here. Let's say 7. Let's say we wake up at 7 in the morning. We'll say that's the AM. Now we could put more numbers here, but this is a quick example. And we'll just change this to and then here we'll put 12. Let's just say that this is a school day, right? Hours. Let's put 3. Everybody gets out of school at 3, right? And we'll say that they enter a value that's between 12 and 3, right? They're in the PM. And then we'll break. And so, let's say if we put in 8, right? That should give us AM hours. And then here, if they put in the number that's between 12, 1, if I put in 12, 1, 2, or 3, that's PM hours. So let's run our program to see what we get. So the value that's assigned to hours, and we have to change day to hours as well. We should get AM hours. Yep. And then here, if we change this to, let's say 2, right, we should get PM hours. Again, this is a quick example just to demonstrate some of the flexibility with a switch statement. And you can add more numbers here to include all the numbers on the clock to determine if it's AM hours or PM hours. But this just quick example of some of the flexibility or some of what you can do with a switch statement. All right, the last thing I want to talk about for this video, because it's getting quite long, is this ternary operator. And this is a shorter syntax of a if-else statement, right? So we have our variables declared, student loan, single, student loan, joint. One of the things that just came down the pipeline on the news from the White House is that there will be some loan forgiveness, and so that's what inspired this program. So if you filed your tax as single, or I can't remember the whole details of it, but if you're a single household, right, you could get up to $10,000 in deduction, or if you filed jointly, you could get up to $20,000, right? So let's do this here. Change that to 20, right? So what ternary does is that it has these special symbols. So there's question mark and this colon. And so you have your condition. In this case here, we have single annual salary. It's less than or equal to student loan, single. And it's almost like you're asking a question. That's the way I like to think of it, is that I'm asking a question in this case. Let me just get my pen out. So here is the question that I'm asking for this condition. And if the single annual salary, which is, in this case, this is $120,000, is less than or equal to student loan single, which is $125,000, then if that condition is true, then it would output this. If it is false, right, then it would output zero deduction. And so in this case here, we have single annual salary, which is $120,000, right, and then student loan single is $125,000. So in this case, this statement is true, that $125,000 is greater than $120,000. So they'll receive, what's going to happen is that $10,000 will be assigned to this variable, single qualify. And so when we output this, it says, if single based on annual salary, you will receive 10,000 deduction. Now, if we were to change this here to be greater than or equal, right, that would then make this condition false. So 120 is not greater than 125. So then they would get this, they would receive this, and then this would be assigned to single qualify. And then what would be output is that if single based on annual salary, you would receive zero deduction. Again, just a quick example. It's a shorter syntax of if-else statement, especially if you just want to shorten your code a little bit. But nonetheless, this is called ternary operator. Stay tuned for the next video.